All right, today we went through the empirical formulation of drag and lift forces, and there's actually very little to really summarize the conceptual work we did in our previous lecture. Now I'm just going to real quickly here summarize the formula that we use, where we have drag force is a drag coefficient 1/2 rho times velocity squared. That represents a pressure dynamic group, where that velocity is the velocity approaching the object. And then we would take times area to convert from pressure to force. AP in this case, so V is the approach velocity, and AP is the projected area. And then CD is a function of Reynolds number and the characteristics of the object. An example of the types of relationships that might exist, one that we looked at today in lecture was drag coefficient versus Reynolds number, where you have a structure like this for, say, a sphere. And this would just be a matter of, for a particular Reynolds number, looking up the drag coefficient and calculating drag forces. If you don't know the velocity a priori, then there's an iterative solution required, but it's not any conceptually different. Lift forces came in two different flavors. We had the lift force of a rotating cylinder or rotating sphere, which is going to be formulated the same way as, so this is just a rotating object. The projected area is the same as in the drag force. The difference lies in the lift coefficient. For airfoils, the area is formulated differently. It's still the coefficient of lift, 1/2 rho V squared, times the span area, where S is equal to the span area. It's like the surface area, the projected area if you look down on the airfoil from above. That's called the span area. Again, 1/2 rho V squared in all these cases provide the dynamic group. In this case, the lift coefficient is a function of the attack angle, alpha, the angle of attack. Oh, I should note in the case of the rotating object, CL is a function of Reynolds number, but also, say, omega, the rate of rotation. That's the angular velocity that describes the rotation of the object. In all three cases, I just want to emphasize that the basic dimensional formulation is exactly the same. It's let me get another color here, I'll get a green. Pressure group, 1/2 rho V squared, times an area, either projected area or span area, and then a dimensionless coefficient, either a drag or a lift coefficient. So it's the exact same formulation in all three cases. It just needs to use some care in defining the coefficient and the area for a particular solution.